Hello and welcome to another video on Further Maths. This is integration in Further Maths. Right, so we're talking about these 4 or 5 types of questions. Integration function is not defined at any value in the domain. One or both limits is infinity. They call it improper integrals, and integrating using inverse trigonometric functions, parametric, and so on and so forth. Okay, guys, the first thing we're going to do is the first two, integrating functions which are not defined at a value in domain. And this is exercise 3A from EDEXCEL book, and I picked up question number 5. Okay, so let us have a look at this question. You can have a look at this question from the book or from here, and we do this together. Right, so textbook questions from this exercise 3A from chapter 3, right? That's the first question we picked up. All right, guys, so how do we integrate this? Using first years of pure maths knowledge, you go to do 7 minus 3x to the power minus 2 dx. Then you use reverse chain rule in here. You use the chain rule first, which gives me the power rule, 7 minus 3x to the power minus 2 plus 1 divided by minus 2 plus 1. Then comes the reverse chain rule. People, what do we have to do? We have to divide this function by the differentiation of that, which is negative 3. Right, so the final thing is, this will be 7 minus 3x raised to the power minus 1. Comes out as this, and obviously this plus c. That's how we integrate this function, guys. Reverse of chain rule. Use the chain rule first, then divide the answer, which was that, by the differentiation of the function, because it's not just x. Right, so in part B, we have to show that this is a convergent function, and we integrate this and find its value as well. Right, so integrating with one of the limits as infinity, the method we use is that whichever limit is infinity, we replace this by a letter t. So this integral will be equal to t and to 2, 1 minus 7 minus 3x squared dx, and we do limit t goes to infinity. It does not actually matter if we write infinity or minus infinity. Okay, so what do we do here, guys? The integral of this, we've already worked that out. So this is actually 1 over 3, 7 minus 3x, and the limits are t and 2, and t goes to infinity. Substitute. Let's substitute 2 into it first, then substitute infinity, see what happens. So when you go further, that gives you limit t goes to infinity, and this is 7 minus 6 is 1, so it's 1/3. Take away. Now, that bit, which is 1 over 3 times 7 minus 3t. And we wanted, like we discussed before, people as t goes to infinity, and if your t is in the denominator, we sorted as this goes to infinity, that goes to infinity. So this whole thing goes to 0. So the answer to this is 1 over 3. So since this can be evaluated, so it is convergent, and its value is 1/3. So once again, guys, two things once again. One of them is the reverse of chain rule. The power rule, use the power rule to the function as normal, but then divide by the differentiation of the function. Then the second thing, when one of the limit is infinity, to replace that by a variable and that put the limit outside, the t goes to infinity. Then try and bring that letter t in the denominator of a fraction, so that the whole fraction gives me 0, and that is where it's convergent. We come on to the next question now. The next question we're doing is question number 7 on exercise 3A once again, and this is integral, okay, and then we want to work out if this integral is divergent or convergent, and it says hence show that it's divergent, it will be divergent. Okay, so guys, let's do this question now. You can have a look, copy that question down in your paper, book, so we can start working on it together. So here you are. That's the question now, guys. Okay. So what do we do in here? We can use a substitution. Which of the two looks more complex? And this is the ln x. That's u b ln x. Then du over dx is equal to 1 over x, which further gives me that dx is equal to x times du. Okay, so replacing dx and ln x by into this function, that gives me ln x is u over x, dx is x du. So x and x cancels. I end up having u du, which is u squared over 2, which further gives me ln x squared over 2 plus c. So that is my integral of this function. For the part B, once again, you see one of the limits given to you is infinity. So replace that by a letter. So I replace this integral and write this as 1 to t ln x over x dx. And I write in front that limit this t goes to infinity. So this is the same thing exactly as this. Okay, now the integral of this, I've already worked it out. So that gives me limit as t goes to infinity. And this is ln x squared over 2, then 1 to t. Right, as we substitute my limits in, guys, I get ln t squared over 2 and take away ln 1 squared over 2 and limit t goes to infinity. All right, guys, so this is obviously 0 because ln 1 is 0. So I'm left with limit t goes to infinity. It is ln t squared over 2. And guys, as t goes to infinity, my ln t goes to infinity as well. So the function diverges. In other words, if you remember, we did say whenever you want to substitute infinity as some of the things, you will try to bring that into the denominator of the fraction. Here we cannot. That's why as t goes to infinity, ln t also goes to infinity. So function diverges. Okay, so moving on to the next question now. All right, the third question we plan to do from this exercise is exercise 3A is question number 9. So we will show you this question now. Okay, so this is it. First of all, let's check why is this question is in further maths. And the only reason for that is you can obviously evaluate, work out this integral in normal maths as well. But over here, you know, this, because as x goes to 2, this function, the denominator will be 0. The function is not defined as an improper function. Okay, that comes later. Let's first work out the integral of this. This is 4 minus x squared to the power 1/3. Okay, the cube root. All right, guys, this is the complex function. Let me just use the substitution. U equals 4 minus x squared. So du over dx is equal to minus 2x. So rearranging, I get my dx is equal to du over minus 2x. So substituting dx and the 4 minus x squared back into the question, it becomes 6x stays as it is. That becomes u to the power 1/3, and dx becomes du over minus 2x. So going by this, guys, that cancels. So I'm getting 6 divided by minus 2 is minus 3. So I take minus 3 outside. And if you take this up there, that becomes u to the power minus 1/3 and du. This is integral which you can handle, guys. The answer would be -3 u to the power 2 over 3 divided by 2 over 3, which I finally get -9 over 2 u to the power 2 over 3 plus c. Okay, but obviously they did not ask me to work out this integral separately, so there was no need to put plus c there. So guys, that integral with the limits is, this will be written as 0 to t, and as t goes to 2, because that makes it infinity. T goes to 2, the function is undefined. This is 6x over that cube root of 4 minus x squared dx. So that this is the same as this. And this integral, I've already worked that out. So that gives me limit as t goes to 2 is -9 over 2 and u is obviously 4 minus x squared to the power 2/3. Okay, and it goes from 0 to t. Right, so let's substitute these values 0 and t first, then see how this function will be evaluated. Substitute t and 0 in it, this is what you get. And as now you put t equals 0, this is the only term which has t, and t equals 2, sorry, that gives me 4 minus 2 squared, which is 4. So this whole thing gives me 0. This one doesn't get affected with t as all because there's no t at all. That gives you plus 9/2, 4 to the power 2/3. And that would be the answer. Right? I mean, if they ask you to show that in any particular form, I'm pretty sure you can do that as well. Okay, so that's your exercise 3A.